Hash functions are used all over computer science. For example, when you're downloading a large file and you want to check if the download was valid, you might want to be able to compare the file you downloaded against the version of it that was on the remote server. But comparing the remote version with your local version would be extremely slow. You would essentially have to re-download that remote file, which would defeat the purpose. You could alternatively hash the file, so compute an integer representation of your file, and then the person on the remote server could compute a hash of their file, and you can compare their hash values. So that's just one context, and we'll be using hash functions to enable extremely fast element storage in some form of a set or a collection. What exactly is a hash function, though? Generally speaking, a hash function is some function that takes as input some object x, whatever type x might be, and it will output an integer representation of x. This is a little abstract, but basically you have your hash function, so I'm going to call it h. Some object goes into your hash function, and then out comes some hash value, which is an integer. So hash functions, to be valid, must have this property of equality. So this is necessary. If x is equal to y, so if I have two objects x and y and they're equal, the hash value of x must equal the hash value of y. So equal objects absolutely must have equal hash values. This is the property of equality. We also have what's called the property of inequality, which is not necessary. This is not a requirement, but it's a nice feature for our hash function to have. The property of inequality says if x is not equal to y, it would be nice, but again, not necessary if the hash value of x was not equal to the hash value of y. So in short, if I have two equal objects, they must have equal hash values. If I have two unequal objects, it would be nice if they had different hash values, but it's not necessary. Let's take a look at some example potential hash functions. So in all of these examples, I'm writing out pseudocode, not real code, because it's the idea that's important, not the nitty-gritty details of actual syntax. And also, for all of these are hash functions that take as input a string. Really, we could have a hash function for any arbitrary type, but in this example, I'm just going to show some for strings. So in this first hash function, we're just returning 0, no matter what s actually is. So s could be the word Nima, it would return 0. S could be the word Moshiri, it would return 0. It'll return 0 for every possible string. This is actually a valid hash function. Remember, the only requirement for a hash function to be valid is that if I give it the same two objects, it will return the same two hash values. So if I give it object x and object y, where x is equal to y, it should return the same exact hash value. And it does. It would be nice if it returned different hash values for different objects, but that's not a requirement. So this is a valid hash function, but it's not a very good one. Because as we mentioned, ideally we want to have different hash values if our objects are unequal. Let's take a look at this one. So what's going on here? I start my output hash value at 0, and then for every character in my string, I add the ASCII value of that character to my string, to my hash value, and then I return that sum. So basically this one is returning the sum of the ASCII values of the different characters in my string. So again, this is valid, because if I gave it the same exact string twice, it would return the exact same hash value. It's better than my other one, because it does give me different hash values for different strings. But one issue that it has is, what if I gave it the string ABC versus the string CBA. This hash value is just using addition, so it's commutative, meaning these two unequal objects will be guaranteed to have the exact same hash value just because they have the same set of letters, just in different order. So this hash function is better than my original one, but it's still not as good as I want. I want to be able to have different hash values for different inputs. So let's take a look at a third example. Again, I start my output hash value at 0, and then for every single character in S, I'm multiplying it by 31. Why did I pick 31? That's a good question that you could probably look up. Basically, I'm multiplying it by a prime number, whatever my current sum is, or my current hash value, and then I'm adding the ASCII value of C. So basically, it's the same thing as this function, except before adding the next ASCII value, I multiply my current overall hash value by a prime number, and then I return it. So again, this is a valid hash function, because if I gave it the same string twice, it would go over the exact same characters in the exact same order. This would return the exact same hash value. And it's even better than this hash function, because if I give it two different words with the exact same letters but shuffled around, this will in general give me different hash values. So it's even better at meeting that ideal goal of having different hash values for different words. Again, remember, the only requirement is that it has the same hash value if two words are equal, but it would be nice if it would have different hash values if two words were different. Okay, so this was the first one I showed. It's valid, but it's pretty bad. This one was the second one. It's valid, and it's better than this one, but still could be improved. And this is kind of the best that I've been showing you for strings. If you want to look at how Java or other languages implement their hash functions for strings, that would be a good exercise. Let's end this discussion with these two potential functions. So this one will just return a random integer. So let's say I feed it the string Nima, and then a little bit later I feed it the string Nima again. It'll return a random integer each time, so it'll give me two different hash values even though I gave it the exact same string. So this is invalid. This is not a valid hash function because I must return the exact same hash value given equal objects. What about this one? So given some string, this just returns the current time. Again, this is invalid. If I run this function given the string Nima right now, and then I wait 5 minutes and then run it again, giving it the exact same string, it'll return two different values because the time has changed. So again, this violates my need of having the exact same hash value for equal objects.